Hello everybody, it's Mr. Vignesh. Today we're going to be solving 1 through 10 of Jim Coroneos' 100 integrals. So let's start with number 1, which basically is outlining x over x squared plus 4 dx. Well, we can set u equal to x squared plus 4. We can set du equal to 2x dx. The top is x, so to make it 2x, you can do half of the integral of 2x over x squared plus 4 dx. So now we already know our u and du, so we can substitute that. So half over the integral of du over u, which is just equal to the half of the integral of 1 over u du, which is just equal to half times ln of u. We know u, which we substituted earlier. We can put our original value back as x squared plus 4. And then we have the half, so we can just divide by 2, plus c, and that is our integral. The next one is very similar. It is the integral from x over square root of x squared plus 4 dx. This time we're only going to set inside the square root into u, so u is equal to x squared plus 4. Once again, du is equal to 2x dx. Same thing as last time. To make the top 2x, we have to do half times the integral of 2x over square root of x squared plus 4 dx. We can substitute it again this time, and you're going to get half times the integral of du over the square root of u, which is just equal to half times the integral of 1 over square root of u du. To solve the integral of 1 over square root of u, square root of u is just equal to u to the half, and then 1 is just equal to u to the 0, so u to the 0 over u to the half. So you can using exponent properties, that can equal u to the negative half. So you're gonna what you're gonna do is do u to the negative half, plus 1 over negative half plus 1. So that's just equal to u to the half over half, which is just equal to basically 2 square root u. So remember, our original was half times the integral of 1 over square root of u du. We got the integral of this to be 2 square root of u. And remember, this half and the 2 square root of u will cancel out, so it just becomes square root of u. Our u originally was the square root of x squared plus 4. And you're going to add that to c, and that is your integral. Number 3 is the integral of 5x plus 2 times x squared minus 4 dx. Let me just check. Maybe I did something wrong. Okay. So we can try to do some. This one, it seems like you could try use substitution, but then you realize plus 2 kind of ruins it. So what you have to do is basically what you do is you can factor the bond to x plus 2 times x minus 2 over 5x plus 2, and you realize these all have the same degree of x, so what you can do is kind of make into partial fractions. So a plus x plus u plus b times x minus 2 is equal to 5x plus 2 over x squared minus 4. So the denominator doesn't really matter. You can cross multiply, if you're going to get ax minus 2a plus bx plus 2b is equal to 5x plus 2. You put like terms, so you're going to get ax plus bx is equal to 5x, so you can say that a plus b is equal to 5, and then negative 2a plus 2b is equal to 2. You're going to multiply the top by 2. Let's just minus these b values. Let's minus all of them, so you're going to get 4a is equal to 8, so a is equal to 2, and then from that you can realize that b is equal to 3, so what our original one was was integral of 5x plus 2, so x squared minus 4 dx. So you can now it's just basically integral of 2 over x plus 2 plus 3 over x minus 2 dx. You can integrate each one on itself. So what you will get basically is for this one, x plus 2, well, 1 over x plus 2 integral is just ln of x plus 2, and you don't need to do, the chain rule will just equal it to times 1, so it really doesn't matter that. So it's going to be just 2 times the ln of x plus 2 plus 3 to the ln, 3 ln of x minus 2 plus c. You can probably simplify this more, but this is how I'm going to keep it. The fourth integral was the integral from sine x cosine to third x dx. So what we're going to have to do is you can make this into sine x times cosine of x times cosine squared x. So what we can do is we can make actually cosine squared and cos x. We can make one of them u and one of them du. So if we set u equal to cos of x, then d of u is equal to sine x dx, which also comes from the dx there, which I should put here technically. So that just become, negative sine x. Sorry, that's my fault. But because we have sine x here, we have to make it kind of like a negative du times u squared du. So that's just dx, which already went away. So that's just going to be negative u to the third. Negative u to the third du. So we need to find the integral of that, so we can factor the negative out. So again, it's negative integral of u to the third du. You can use the reverse power rule, so you're going to get negative u to the fourth over 4 du. Remember, we said u was cos, so it's going to be negative cos of x, cos of fourth over x over 4. You're going to add that to c. Okay, this next integral is actually really interesting. There's two ways to do it, but I'm going to show, and actually you may get two different answers. So what okay, so this is to third, right? Sorry. So so what you can do is what I made is this. I just made this equal sine of x divided by cosine third of x, and that's just equal to sine of x over cos of x times 1 over cos squared x. So sine of x over cos of x is equal to tan of x, and then that is equal to sec squared of x dx. The thing is, what you're gonna get is you're gonna get u equal to tan of x, and then du is equal to sec squared x dx. Sorry about that, dx. So then that's just going to become the integral of u du, which is just equal to u squared over 2. Well, u squared we said was tan, so you're going to get tan squared x over 2 plus c. Now, there is a clash here, though, because you actually can get two answers. What you could do actually is, yeah, you can go back to that way where you did sine of x over cos of third of x dx. You find the integral of that, but then you could set u equal to cos of x, and then you could set du equal to sine of negative sine of x So the top becomes negative u, and then the bottom becomes divided by u to the third. So what you get through this is you get sorry, this is supposed to be negative du. I'm being really dumb. Negative du, and then so you find the integral of that, which is just equal to integral of negative 1 over du over u to the third. So that's basically just negative u to the negative 3. That so the integral of that is u to the negative 2 over 2 from the reverse power rule. You can add that to, so u we said was cos of x, so that's going to be just half times, well, u to negative 2 over 1 cos squared x, so that's actually just sec squared x over 2 plus c. But we said that it is tan squared x over 2 in a different method. Well, it actually really doesn't matter. You can get both and it's still correct. The thing is, tan squared of x is equal to sec squared x minus 1. So pretend we had our tan squared answer over 2 plus c. Now when you factor this, you're going to get sec squared x over 2. Well, not factor this, make it into multiple fractions plus c. But remember, negative half plus c, negative half is a constant by itself. So a constant plus a constant is a constant. So this can just become c by itself. So both the methods are technically right, and properties can prove that. Okay, the next one was cos squared of x over 2. Integral of cos squared x over 2 dx, I believe. Yeah, dx. So you can use we can say that cos of x over 2 is equal to, you can remember your half angle identity. That'll become plus or minus 1 plus cos of x over 2, and then if you want cos squared of x over 2, you can just square both sides, square this. So you're going to get cos squared of x over 2 equal to 1 plus cos of x over 2. So now you can just what you can do, you can just differentiate this. So that's going to be just half times the integral of 1 plus cos x dx, and then dx, the integral of 1 is x, the integral cos of x is minus sine x, integrals plus sine x, over 2 from that plus c, and that is your answer. Our next one is the integral of x sine x dx. So this one all you really have to do is just try integration of parts, honestly. So you can use a Lyot rule, and we know that algebraic comes over trig. So we can set x equal to u, du is equal to 1 dx, just dx, I'll say, and then v is equal to sine of x, and dv is equal to sine of x, and v is equal to integral of that, which is just negative cos of x. So you have u and v as x and negative cos of x, so multiply those, cos of x, and then this is by integration apart, so integral of du, which is just 1, or dx, so I'm actually just going to say dx, and I'm going to put it here, times v, which we said was negative cos of x. So the integral of am I messing something? I feel like I'm messing something up here. Du times v. Is there a negative supposed to be there? Because give me a second. I'm blanking out a little bit. X times sine x, so x sine x du is equal to 1 dx, and then v is equal to negative. Oh my god. V is equal to cos of x. Why did I say negative cos of x? Wow. That's my fault. That's a little bit of mishap. So yeah, so this just becomes that. So the integral of cos of x is just sine of x. So that becomes negative x cos x plus sine x plus c, and that is your answer. Number 8 was x times sec squared 2x. Sec squared 2x dx. So, what you can do basically is we know that sec squared x is we can do integration of parts, but so we kind of already know that u is going to be equal to x du is equal to dx, and v is equal to dv is equal to sec squared 2x, and then v is just the integral of that, and we know that the integral of sec squared x is tan of x. But remember, we have a 2x, we have to make it 2x, and then you have to account for that by dividing by 2. So v is equal to tan of 2x over 2. So we can now multiply, so you're going to get, okay, you're going to get uv, so that's going to be x times tan of 2x over 2 minus the integral of, well, you're going to have a half there, so we're going to just bring the half out here, minus tan of 2x, 1 times tan of 2x, well, dx times tan of 2x dx. So well, you can see the integral of tan of 2x is just going to be, that's just going to be, well, we have to solve the integral of that, we have to set that equal to sine of 2x over cos of 2x. Well, yeah, so like it's going to become, you can make that into, well, the derivative of cos of 2x on the bottom is negative 2 sine of 2x, so over cos of 2x. So to take it out, we can put a negative half, a negative half in the front, times negative half we already have, so that becomes 1/4. So now we can make this into u over du, so that's just going to become 1/4 times the integral of du over u, which is just going to be equal to 1/4 of the ln of whatever our u was, which was cos of 2x. So that's also including the half that we put out originally. So so our final integral is x tan 2x over 2 plus ln of cos of 2x over 4 plus c. Q9. So this one was probably the hardest one for me to solve, but then I realized that it's actually not that hard if you know. So it's just the integral of arctan basically of 2x dx. So what we sometimes in situations if you don't have any strategy like this, and there's only like one element, then you actually still use parts, and you set dx basically to dv. So we can set u equal to tan negative 1 2x 2x. Now the derivative of that, remember, it's going to be 1 over 1 plus x squared. But remember, we're using 2x, so it's 2x squared, which becomes 4x squared. X squared. And you have to account for that with the 2 in the top. So that's equal to 2 over 1 plus 4x squared. Then we can set dv equal to dx, and then v is equal to x. So then your final thing will become, using integration of parts, x times tan negative 1 over 2x minus the integral of 2x over 1 plus 4x squared dx. Well, the bottom, remember, the integral of the bottom is, we can set this equal to u. Sorry, and the derivative of it is 8x, but we need to get ax on the top, so we can do minus 1/4 of the integral of ax over 1 plus 4x squared dx. So then you can get negative 1/4 of integral of du over u. So that's just going to become basically negative ln of, what was our u? 1 plus 4x squared over 4. You're going to be, so that's going to be that part. So you're going to have the original x tan negative 1 of 2x minus ln of 1 plus 4x squared over 4 plus c. Now our final integral was x to the third over x squared. Sorry, x to the third over x squared plus 1. So you're going to, what you can do with that is, give me a second, something glitched out. Okay, 1 over x to the third equals x squared plus 1. Basically for this problem, what you have to do is you have to try to like get something with x squared plus 1 on the top. So we have x to the third, so we can times that by x, and then that's going to equal to x to the third plus 1 plus x, and you have to minus x to get the top to satisfy. So you can just make this into like kind of like partial fractions. So the top is going to, the first one's going to be x, and it's going to be minus x over x squared plus 1. Of course, the integral of x is x squared over 2. Sorry, now I'm thinking of something. I feel like on one of the problems I put 1 as the integral of something. As x. Did I, yeah? Never mind. Let's, if I did, I probably made a mistake there, and I accidentally did that, but maybe I did. Maybe I didn't, I don't know. X squared minus 2 minus, well, x over x squared, remember, if you want to find the integral of x over x squared plus 1, then you have to factor the half out, so it becomes 2x over x squared plus 1. So it'll be half over integral of du over u, which will equal half of the ln of whatever u is, which is x squared plus 1. You can get minus ln of x squared plus 1. Divided by 2, I believe. Did I forget the 2 yet? No. Divided by 2 plus c. And that is our answer. Okay, so thank you for watching this video.